So I'm going to talk mainly about the CO2 project, which is, well, the project's called a prototype system for a Copernicus CO2 system. And it's largely about monitoring human or anthropogenic carbon dioxide and methane emissions, although a lot of the focus is on carbon dioxide. And that sort of subtitle there, from science to operational services, is quite important. So CO2 is trying to move some of the activities that I'll talk about more from the science space into the operational space. So how can we make these activities more routine? But what I want to do is give a bit more of I guess my presentation is going to be a bit more of a background, covering some of the key topics and issues. And then in the following presentations, when you hear about the other projects, you'll get a bit more detail. So, stepping back a little bit, how do we estimate fossil CO2 emissions, and in a sense, why? I'm talking primarily about fossil CO2. I'll mention things like methane and land in a minute. And what I'm going to talk about now is often called bottom-up or inventory-based approaches. There is ambiguity in what that means. But to simplify it, what we do when we estimate fossil emissions is we take the level of activity, for example, the tons of coal, and we figure out how much carbon is in the coal, and we take tons of coal times emissions or carbon per unit coal. That's a little bit simplified approach. There are some complexities that you can add in, and particularly when you get to the land sector or the agricultural sector, you might even use models. But generally, we're using statistical data, activity time, emission factor. And when it comes to fossil emissions, we think that we can probably estimate emissions in a developed country at least within a few percent. So we can do a pretty good job, you would think. But there are some uncertainties. Are we really sure that we can estimate emissions so accurately? Do all countries have equally good estimates? And what about if you go from a country level or regional level, let's say Europe, down to much smaller scale, so cities and facility or point sources, industrial facilities or something like that, then uncertainties might go up. And to give a good illustration of some of the uncertainties, that figure there on the right-hand side is energy consumption in terms of coal use in China. And it shows some of the revisions that have happened over the years. So if you look at the green line there, the first line at the bottom, it looked like coal use in China peaked around 1996 or something, and then declined to around about 2000 before it rose again. And a few people were a little bit suspicious of this, and actually a few years later, some scientists using satellite observations of NOx, nitrogen oxides, were able to say, well, we're not really sure about this. And ultimately, in various census revisions, the Chinese data has been revised, and quite significantly. So that initial dip around 2000 basically no longer exists in the latest data. And so this is a good example where satellites have helped identify problems. And when you look later into the years, into 2010 or so, you can see that the different estimates also have quite a big spread, 10 or 20%. So when you get to developing countries, maybe there's uncertainties of 10 to 20%, or even larger in some countries, and therefore maybe other methods to estimate emissions could come in useful. And I'm talking about fossil emissions at the moment. If you go to land fluxes, what's happening in forests, for example, or agricultural sector and methane, things get way more complex. So then comes the question, what about using observations? How can we use observations? So can we use observations to estimate CO2 emissions? Well, and I guess methane and so on. Short answer, I guess one way you could say it is yes, but it's not so simple, or there's a lot of uncertainties involved. And if you look at the top figure there to the right-hand side, that's CO2 concentration in the atmosphere, globally averaged. We can estimate that very accurately to within a couple of decimal places. However, that does not necessarily mean that we can therefore estimate the CO2 emissions that lead to that concentration in an inverse sense. And the bottom right there, we have some sort of estimates of the averaged column concentration of carbon dioxide as seen sort of from space, if you like. And that gives you an idea of the complexity of the situation. So for example, the concentrations can be high over ocean areas where you might not have emissions and so on. So it's not going to be that simple to estimate emissions directly from observations. And particularly CO2 has some challenges. It's a very long-lived species and it has complex interactions. So CO2 can come from a variety of different time periods. So the CO2 that you're sort of breathing in now, if you like, that could have come from a car that was driven this morning, or it could come from a coal plant that was used, 100 years ago. There's a variety of sources. There's fossil sources, there's land-based sources, there's respiration, we're breathing in or breathing out CO2, trees are taking it in and so on. So it's actually quite complex to go from observations of CO2 to the emissions of CO2. Another issue is that observations are often very specific locations and have very high temporal resolution, whereas quite often when we're looking at what are our emissions in our country or our city, we're talking about yearly averages and that sort of stuff. So there's a few different connections that we have to think about. But the value of the CO2 observations come in when there's a range of other observations, let's say a constellation of observations, and it's linked to models. And this I'll talk about in the next few slides. So this COCO2 project is a lot of what it's doing is leading up to the launch of some satellites in 2026 or so, the CO2M mission. And these satellites will, rotate around the Earth and take measurements of the column of CO2. But that's not necessarily perfect, as you see in the bottom left there, that it takes various strips, if you like. It's not covering the whole Earth at the same time, so it's just certain specific locations at specific times. And there might be specific conditions, like there might be clouds. Oh, okay, it might be over the ocean, and there's things like glare that you experience. Satellites also experience that. And so the observations need to be supplemented with other observations to fill in gaps in terms of times, to provide calibration, to make sure we know what the satellites are measuring, providing complementary information. For example, a fixed site measuring fluxes gives a different sort of information and so on. And different observations, you can apply different methods. So the important thing here is that observations, or the different types of observations, are really one piece of a puzzle. And the more types of observations we have, then the more pieces of the puzzle that we have, and therefore we can fill out a picture of what's actually happening. So we just can't use satellites or just can't use flux towers. We really need a combination of all these sources to get the most value. One important thing is you have all these observations which are coming in, and you need to somehow assimilate those observations, and you need a model to interpret all this stuff and estimate the emissions, considering the weather patterns, the airflows and so on. So this is a figure by a colleague which sort of gives a bit of an idea of what's happening there. Maybe I can try highlighting. We've got certain types of observations on ground, let's say space-based observations. We have prior estimates of emissions, what we think emissions might be doing, and these all go into a model, and then the model spits out what is hopefully a better estimate of the emissions. And sometimes with sectoral detail, not always, depends on the species. And this is essentially what's known as a top-down or observation-based approach. And the output from that is the emissions data is usually gridded, so it has high spatial detail, can quite often have a lot of temporal detail. Sometimes, depending on the species, it can have sector detail. One challenge is it generally includes variability. When you're modeling flows and weather patterns and so on, you'll pick up variability if it's dry period, wet period, and so on. And these methods are often used in scientific research for a whole variety of applications. The alternative approach, or another approach, the bottom-up approach, which let's say official emission inventories use, the inventory approach, generally country level, could also be city level and so on, generally over a 1-year time period, so annualized data. Sector level is very important. If you ever talk to inventory people, they're always talking about sectors because that's essentially the way the inventories are compiled. Variability is averaged out over time periods. So if you think about the forest uptake, it's often using what's called a national forest inventory, which sort of averages out the variability over time. which is a challenge comparing to other approaches, and it's used in official reporting. So a lot of what we do in projects like COCO2 and other projects is take these different approaches and try and reconcile them and see why they differ. If they agree, that's good. If they disagree, why do they disagree? Does it mean that one estimate's good or bad, or something like that? Trying to understand why there's variations. So coming a little bit more specifically to the COCO2 project, this is the sort of, this structure here I've got on the screen is known as the CO2 monitoring and verification support system, which also links very closely to the work package structure in COCO2. And this relates to the fact that this is very much a science to operational type activity. But you see all the components that I've talked about in here. Observations of different types all sit over here. Integration is essentially modeling, and the modeling can happen at different levels. It could be, large scale all the way down to looking at plumes coming from power plants and so on. So city level would also fit inside this box. You need some prior estimates of the emissions in these systems, and you get a new estimate coming out here. And probably one of the most important parts, which is just a small little box, a little bit downplayed, I think, is a decision support system. And this is really where the user services link in. So all this information here feeds into this decision support system where we hopefully get utility out of the work. And this is something that I work on in the COCO2 project, and I would argue needs a lot more attention. Just quickly, I'll say something across scale, zooming in a little bit to the city level, but the following two presentations, you'll hear much more about this, particularly coming from my perspective. I'm more coming from a national perspective, and many of the applications with this verification at the moment are quite often done at the country level, not always, but quite often. At city level, you have additional challenges. Inventories are much higher spatial and temporal detail. You could be talking about roads, particular facilities and so on. And estimating those inventories from bottom up, you have lots of problems with confidential data, system boundary issues, etc. In the cities, you also need a strong observational network because you're looking at different aspects of the problem. When I speak to colleagues in Norway, for example, they'll have very specific questions, things like, we don't know how to estimate, or we need a better estimate for methane from our landfill. But the landfill is within the city, it's only a small landfill, so you might need to use different types of techniques to estimate those emissions. And point sources require methods to detect plumes and so on, so it starts to get complex in a computational or modelling sense, how you may isolate these plumes from the background emissions. That's sort of what's shown in the bottom right there in that figure. But I'll just sort of say more broadly, it's an active area of research, as you'll hear in the next two presentations, on how to reconcile these different approaches, how to use observations to make accurate estimates and so on. And to finish up, I'll just talk a little bit about the decision support system. That's that little box I mentioned that sits to the side there all by itself. This is about how to take the complex information generated from the observations and the model, so the rest of the system, into a format that is useful for the user community. And we probably have not done enough work figuring out what users actually want, what services do they want, what questions are they trying to answer. If modelers go speak to inventory agencies, quite often you learn their concerns and questions are very different to what a modeler's concerns and questions are. So what sort of observations and methods can help answer the particular questions that a user may have? And I guess maybe this is a bit of a sales pitch. In the COCO2 project, we have a decision support blueprint trying to outline some of the aspects of this decision support system. We'll do a revised version of that, so you're free to have a look at that document and provide feedback and comments, particularly if you're coming from the user side. And with that, I'll finish up. Thank you.
Great, thank you, Glen. I think that set us up very nicely for the next couple of talks. The blueprint you're mentioning is now in the chat for anyone who needs the link. And I don't see any other questions in the chat now. So I think we'll move on now to Claudio. from ICOS Cities. So thanks again, Glen.
Thank you.
Good morning, everybody. Well, thank you very much for having me here. Well, we just can flawlessly continue with the word blueprint from Glen. Thank you very much for your talk. You have pointed out the very much important topics, I think, from this whole system of CO2 or greenhouse gas measurements, what we are looking into it. So ICOS Cities or PAUL is a pilot application for urban landscape measurements. And what we try is to, well, I really have to just point back to Glen to like remove uncertainties in measurements, to check innovative methods of measuring within the cities, to bring these uncertainties down, to provide more of those puzzle pieces for the overall modeling strategy, I think, so that we can go on global national parts. So this is what we are doing, and rightly pointed out, the connection to useful services and tools is absolutely paramount, I think. And so you have to move this picture a little bit away. There we go. So we have 3 pilot cities. I can move on. 3 pilot cities I will talk about in a bit, like in many countries involved in this. And but coming back to the name ICOS Cities, I don't want to talk about ICOS. I guess you all know this European research infrastructure about CO2 measurements, which is looking, and this is what I want to highlight, into atmosphere, ecosystem, and ocean measurements. And we have standardized this. ICOS is operational, providing data to the community. And looking forward, I think ICOS Cities should aim for being the 4th pillar within ICOS to provide the data from the cities. Antonio Guterres said this, I think, very to the point, that the climate battle will be won or lost in the cities. We have, depending on what sources you're looking at, but one can be sure of more than 50% of all the emissions globally are coming from the cities. So it is really a little bit of a kind of blind spot we have in regards to measurements, I think, or where we're building up these capacities in many cities. It is not just our project here. There is many efforts in other countries and cities. I don't need to convince you why we need to reduce those emissions. I think this audience is well aware of this. And I think it is really, it has shown in these previous talks as well, there are many possibilities within cities to reduce the emissions. And what we are trying to build up is this capacity of a urban observatory, and how to do it best, and how we can produce input for the models. Our key objectives a little bit, as I said, reliable data is very important. We have these pilot studies in those 3 cities, which are mid, small, and big, with different topographies and different challenges, I would say, but should give us an insight as in what methods will work in what environment. We really aim to have some services and tools for our stakeholders, for the cities, for the citizens, to support policymakers, And obviously we are part of the European Green Deal and really try to support this effort within Europe to bring down the emissions. This is our network we are looking at, and you will see in a bit when Tuukka will take over that we have an overlap in our network. So we have those 3 pilot cities I mentioned already, which will have a huge amount of infrastructure measurements done, and 12 network cities or associated cities, and they build up capacity as well and really try to learn from our lessons what is working and what not. And we're trying to bring the people together to bridging their gaps from those networked cities. Basically just what I said, so I can skip this slide. So one point we are really trying to do in ICOS Cities is, and I would say not just measurements, but it is a way more complex situation. And measurements data is obviously one very important bit, but then you have this kind of infinity sign here, where we really try to have a co-design approach or as many iterations as possible to go round and round. So if you have models, they say, well, we need better data, and then you can go to the left down, and we can say, yes, we can try to improve data, and then that goes back into models, and then they produce some services, and the cities say, well, yes, it is good, but you know, it's not good enough. We need more. We need a better emission map, and then so this is the iterations we are very much involved in. So we have our work focused on measurements, but as well to outreach to schools, to the cities, to get everybody on board, because we need to know what it is working and what kind of tools can improve, especially towards climate action plans within the city. It is good to have something to plan for, but if you then cannot verify and monitor your efficiency and the effect of your implementation, then it's not moving forward. And this is why we are trying to have this integrated design approach. And this is the part from ICOS Cities where we, as I said, we have a strong focus on monitoring and measurements. But one part, which Glen already mentioned as well, high resolution emission inventory is paramount for everybody. And this is where cities can come back in, and we can hopefully work together how to make this better. But this goes into climate governance. It is a benchmarking of services which we are doing. We have ongoing interviews with stakeholders from academia to the private sectors. So there is a lot going on. And what we have on board as well in our project is ESS, the European Social Survey. They are preparing a first wave of behavioral and attitude questionnaire. I think about 2,500 people will be asked. So that should us really give insight how and where we can bring our knowledge from the scientific world to everybody. And the other part is modeling, as Glen mentioned as well. You saw this picture from Glen where you had this little dot of a city in one of the pictures. And so if you look at just cities and you really improve all the inventories, and this is one approach I'm showing you here now, where in Zurich it is going down to road levels to buildings. So it really highlights where emissions are taking part. You can look at point sources at the roads itself. So this is a very nice ongoing work, and I think we should really be able to provide a lot of input to COCO2 and the other way around as well. Measuring, I can just as a quick overview, you can see we have remote-based column observations as well. This is, what is it, number 3. So which is basically the same as from a satellite coming down, but we have instruments pointing up, measuring essentially the same. So we can each verify each other's results or data. And we have much more going on in a city. We have different techniques for flux measurements. We have instrumented parks for the biogenic fluxes to compare what is the anthropogenic and biogenic, and to really partition this, or we're trying to. So there is a lot going on here. And last but not least, it is, as I said, the communication and engagement with other people. So we have this city network where we try to engage as many cities as possible to really create a blueprint for European cities, to say, well, if you have this kind of city, this approach and these instruments may work, and this is how you could potentially talk to the government and the citizens. And one part of this is as well that we have a scientific experiment designed for schools. So we have workshops in schools teaching the teachers and the kids what climate change is and how you can measure CO2, and they will get little instruments to measure CO2 and just be aware of this situation. At the moment only in German, but we will translate this into French and hopefully English in due time. So the lessons learned so far for us is location is very tricky in cities to achieve permissions. It is very time consuming, and you really need to have a plan B for this. Point sources have shown up as in a difficult question, not just to pinpoint them, but what you do with it. At some point they will be like background, but they can be very important if they are close by. And from a social interaction viewpoint, it proved tricky as well that interviewing people is hard, and you will get not many people taking their time for it. And I think this is why one good thing of this talk we have right now here, to bring different projects together and hopefully talk to the same audience from different angles and aspects, is it's very important to be time efficient, and that people from outside academia get the whole picture at once and not in little morsels over time. I started to put the acknowledgement slide together. I failed. There were so many people. So I would just thank all of our partners and beneficiaries within the project. So I just put up the logos here. So we are all across Europe, and thank you all for participating in this project and providing, good work. And take-home message, yes, we want to create a blueprint for the urban landscape and really provide services, tools for citizens, policymakers, and the education. And with that, I am finished, and thank you very much.
Thank you, Claudio, for a great talk and overview of the ICOS Cities project. I still don't see any questions in the chat, so I will open the floor for Tuukka. And any questions to any of the presentations, just go ahead and put them in the chat, and we can have a discussion after Tuukka is done. So, thank you.
All right, thanks, Ida. Good morning, everyone. I'll try to put it on the full screen mode. So my name is Tuukka Petäjä from University of Helsinki, and I'll talk on behalf of the project RI Urbans, which is which has a long name: Research Infrastructure Services Reinforcing Air Quality Monitoring Capacities in European Urban and Industrial Areas. And this is an activity coordinated between University of Helsinki and CSIC. And oops, go to the next slide. The background for our project is air quality. So, and in air quality, the concern, of course, is the aerosol particles, atmospheric particulate matter, ozone, NOx, ultrafine particles, black carbon, and things like that. And even though the air quality has improved in Europe, there's still a very big fraction of population who is actually exposed to exceedances in air quality, and this is what we tackle in the project, and also bring into the table new observables that are relevant for health impacts, such as the ultrafine aerosol particles. And here's the consortium and the coverage in Europe. So big fraction of the member countries are participating in the project with 25 beneficiaries, and also the JRC from the European Union Research Center in ISPRA is taking part. And the whole idea of the RI Urbans is to bring together research infrastructures. So as Claudio was explaining, the ICOS, which is the Integrated Carbon Observation System, the relevant European infrastructures for air quality are ACTRIS, so aerosols, clouds, and trace gases infrastructure, and IAGOS. IAGOS is making measurements on commercial aircrafts on air quality, and they provide the vertical profiles and regional dimension of air quality. And ACTRIS is making ground-based remote sensing in situ observations in different sites. But the challenge within ACTRIS is that many of the observation sites are outside of the city environments, and to actually move forward into the air quality that is relevant for big part of the population living in the cities, we collaborate with air quality monitoring networks, and also hopefully bring some of the infrastructure expertise that we have, and combine that with their expertise on their measurements and understanding of city level air quality parameters. So it's I would see that as a bidirectional collaboration, where both all the parties learn from each other, and hopefully we have at the end a better view of the air quality within cities. So we need comprehensive observations and models, and this is the also in the background of RI Urbans to use all the potential measurement capacities and tools to understand the processes and different sources of air pollution in urban area. So within the project, there's part where we develop service tools, and then these include, for example, new observations on nanoparticles, ultrafine particles, or aerosol analysis of aerosol sources in the urban area. So we develop the tools, and then we demonstrate these tools in several pilot cities. So we have 9 pilot cities and 5 pilot actions, which demonstrate the capacity of the RI Urbans and the network to develop and utilize then these new observations. So the pilots are 2 of them. Actually, if we go to Okay, maybe I'll explain this slide to the end. So we develop the service tools, demonstrate them in the cities, and then we aim to upscale the developed pilots into research infrastructures and also try to find ways that some of the pilots and activities are taken up by city level or national level air quality authorities. So to have a continuation of the developed services and tools, we look towards the city collaborators as well as the research infrastructures that can provide continuation of the activities after the project. So the pilots that I will be talking briefly, so I introduced them briefly, and if you want more information, please send me an email or contact me later. So the pilots that we have is near real-time data delivery on 2 parameters. So analysis of aerosol sources. So where is in a given measurement site, whether it's a roadside or close to a harbor or where it is, we provide analysis that what is the relative contribution of traffic and for example biomass burning or secondary formation, and this is provided in near real time. In selected pilot cities. The other near real-time data service is about nanoparticle size distribution. So the smallest particle number concentrations we deliver in real time in pilot cities, and this is relevant, for example, understanding for example, the road traffic impact on number concentrations and therefore the health effects of the aerosols. The pilot activities also include fine scale mapping. So there where we combine mapping with modeling and monitoring and crowdsourcing. So we also interact with the citizens and also with local city actors who gather air quality data. The health pilot looks into novel health indicators, and one of the topics that we are interested in is oxidative potential, which is it describes how reactive is the aerosol particles once they enter the human body. And of course, we compare the health indicators with the near real-time data and aerosol source apportionment. And then as the 5th pilot, we have quantifying hotspots. So what is the impact of harbors or traffic, road traffic to air quality in the pilot cities. And we have these 9 cities who are involved in the work: Athens, Barcelona, Birmingham, Bucharest, Helsinki, Milano, Paris, Rotterdam, and Zurich. And they take part in different activities in these pilots. And we have at least 3 cities in all of these pilots. And then the others are replicating the results later on. So it's also planning and thinking about how to scale up these pilots during the project and also after the project lifetime. Going through the different pilots very briefly. So this is the source apportionment, which is Paris is one of the key cities. So this is an example of the tool that will be available. So provision of aerosol sources based on observations done in Paris. So these pilots require measurements with an aerosol mass spectrometer, and then the project provides tools for analysis of this data in near real time, and we can identify the hydrogen traffic emissions in red, for example, and the biomass burning in yellow here as a function of time. And then organic aerosol formed in the atmosphere is in this case dominating the mass concentration, but we can follow their relative roles over time in near real time. The aerosol number size distribution is done again in 3 different cities, Helsinki, Birmingham, and Barcelona, and we already have 2 volunteering cities providing the same data. So this is number of particles larger than 10 nanometer in diameter in different environments, and this is very highly variable data, reacting very quickly to local and regional emissions and their changes. So this is relevant also in that sense that the measurements are done in urban background, but also urban traffic environments, and from the level where people are breathing. So it's health related parameter arising also in the coming air quality directive or the draft of the air quality directive. As an example for the mapping activity, I just show Paris. Just identifying the scales that we are aiming to. So going into street level understanding. So the top figure is NOx concentrations in Paris, and highlighting the streets and the traffic emissions. And then the one on the bottom is particulate matter concentration, and also their areas close to the roads are highlighted as hotspots. But this is something that the mapping helps also the analysis of air quality in a smaller scale. And as a application of both modeling and measurements, this is results from Bucharest, where there is a mobile measurements on a route within the city, and supported with modeling results. So this kind of analysis is helps to understand the local hotspots and also their variability within time. So it takes actually 8 hours to do this kind of route of measurements, but provides a valuable data set. The health effects are one relevant point for air quality in general, and as I said, one of the key things there is the oxidative potential, and we are analyzing existing data and also collecting new data on oxidative potential, and also harmonizing the methods to determine the oxidative potential. So this is something that will be then available after the project. So how to do the oxidative potential measurements, and then analysis on how that is connected to the citizens' well-being. So it's not only the mass of the aerosol or the number of the aerosol particles, but it's also how oxidative is the inhaled aerosol. And the last example is the hotspots, and this is actually connecting to the environments where there is also at the same time high CO2 emissions. So this is around Rotterdam. So there's very high intensity activities in the harbor area with high CO2 emissions, and the team is distributing air quality observations around the harbor area, and also utilizing citizens and volunteers to bike around the area to map out, for example, NO2 concentrations within this specific area. So we already have a list of service tools. So these can be found from the RI Urban's website, including best practices and methodologies, but also related to near real-time data delivery, production, and acquiring the near real-time data. All right. So thanks for your attention, and I'll take the questions and the discussion. Here's my contact details if you want to reach me after. Thanks.
Great, thank you, Tuukka. And that was the final presentation we have today. What we have now is time for a discussion. We have a few questions in the chat, and I will start with the first one that came in. So is there any overlap between RI Urban, ICOS Cities, and Actris in terms of co-located measurements? Is that something you have? So Claudio or Tuukka?
Yeah, first of all, some of the pilot cities are the same. So Paris and Zurich are same. So that's a starting point, at least those two. And then the ICOS cities have the follow-up cities, for example, Helsinki, where we also have activities. So that's the one of the goals that actually also materializes in these events, that we organize these together. So we have activities in the same cities, and it's important to make the connection, as I said, showed and in the last slide, the high emissions from a harbor area from the CO2 point of view, and at the same time they are relevant for air quality, local air quality. So we have how to put it, we try our best to find these connection points and build on these. This is an ongoing process, so maybe Claudio can continue, but yes, idea is to make these connections and also involving then the local stakeholders within the cities where we have several projects working. So that's one of the key things. I support the idea that collaboration with regional and city level stakeholders is the key, because they know best what is really happening in their area. So this is what we want to do. So maybe Claudio, you can continue.
Yeah, well, there's not much to say. I can only agree with what you said. Maybe one thing to point out, that we do not, as far as I'm aware at least, have co-location of instruments as such. So we have an overlap in cities on that scale, but not on instruments itself. Mm-hmm. But maybe I will just give the word to Werner. He has raised his hand, and he can continue on that point.
Yeah, I wanted to start with a question to Tuukka, and I might explore with this question also the potentials of co-location. You said you have particle measurements that you can attribute to specific sources. Mm-hmm. Right? Do you attribute this to specific sources, let's say like traffic, or are you attributing it to traffic in a specific road?
If I understand your question right, we are not able to identify individual cars, but we are able to connect the emissions to the traffic nearby.
Okay, that's the background of my question. if we have inventories and also if we have, of course, concentration measurements of related to air quality of particles or of NOx, for example, then it is important for the work in the cities that we can, in a way, map them, that we can get local sources or source areas. And we can, in a way, say, easily state that some of the greenhouse gas emissions and some of the particles or some of the air quality related gases are coming from the same sources. But still there might be differences, and I think in a first step it's important that each of the projects solves their mapping and solves their observational capacities in the area related to their own path or to their own questions, which means greenhouse gases, in particular also methane, is different to map than N2, for example. So that's the reason why perhaps the Commission has asked for 2 projects. So they had separated this in the proposal. But then there is a second step. As I said, the sources are very often the same, like traffic, where we should bring these results together. But I would not say that this is instrument-wise or concept-wise the first step. I think that's the second step. And as a second step, or preparing the second step, I think we have already now things like transport models, which are the same for greenhouse gases and aerosols and NOx, for example. So I think here the cooperation could start immediately, and I think it's even already going on. I'm quite sure that in some cities we are exactly using the same transport models. And that's something I think we could intensify between the projects. And then we might also have a closer look at the observational networks. But this requires, I think, first some experiences with the networks we are testing on both sides. We are testing, as Claudio said, we are testing a number of methods that have never been applied in this way in cities. And with this experience, I think it's easier to come together in the end and talk about a common observational system, which definitely is the ultimate goal of the 2 projects, to work together towards these two questions in one observational system. That's at least my idea.
Yeah, I think I agree that we need to do our own homework first, and then find the win-win. But yeah, I agree. So this is the step 2, as you said. There's a question from Paul Smith about noise. So we don't have noise measurements associated in RI Urbans. But there is currently a call open that will target hotspots and noise. So this is something that the Commission has realized that it's a relevant parameter for quality of in the urban area.
Okay, great.
Did I miss any of the questions, or did I? You are.
That's great that you answered that question also. There are a couple of unanswered questions in the chat that I won't have time to go over here. Anyone who wrote those questions, please contact with email any of the speakers if you would like to have them answered. But for now it's 10 o'clock. I think we could do another question if the speakers are willing to stay. And that is about outreach, or it's, I'll read, it's really great to see the outputs for users, stakeholders, policymakers, etc., and then the engagement with users. Are you finding that users are happy to contribute resources, such as personnel and or funding, to develop these outputs? So open up for the speakers.
Well, this is a hard to answer question, I think, because this is probably only in a further down the line. So providing funding, time, personnel, I don't think we are really there yet, because at least from my viewpoint, what we are trying is to really engage with government people, with the citizens, to engage them. So we are not at a point where we can say, well, you should now be doing this, hence you have to provide personnel and money to do something. On the other hand, I can say that those workshops within ICOS Cities, at least, we have organized with the schools, to bring them experiments to teach the kids about climate change and things like this, we are welcomed with open arms, I think. So people are aware of what's happening, and they would like to get engaged and involved, and they don't know how exactly. And I think this is a little bit what we should, come together and have as an outcome, as in, how can we engage? What can you as a person do? What can you as a city government do? But yes, it is a little bit further down the line, but in essence, I would say from my perspective, yes, they are happy to contribute. I hope that answered. I think this was a question from Chris. Yeah. So.
Yes, that's great. Does anyone else want to fill in? I see, Glen, you've been replying a bit in the chat also.
Yeah, I can fill in a bit. I think it depends a lot on the user. I use the example of the UK and Switzerland in their national inventory reports. They already use inversion modelling and verification as a sort of a supplement, if you like. That's in an annex in their report. So they've already allocated resources. So they're keen in a sense. If I think to Norway, so where I have more contact with the inventory people here, I'd say they're interested and they're keen, but we don't have answers to the questions that they have. So they're very engaged in the processes they need to follow. So Norway, for example, had some critiques of the modelling of soil carbon in their national inventory. And so their focus is they want to improve the modelling of soil carbon, but that's not something that we will be able to help. They've got a lot of uncertainty on methane emissions. Not sure if their sources are big enough for us, or for a satellite, for example. A lot of uncertainty with HFCs, but excuse me, not sure we can help. So it's a matter of finding where we can offer the most supports to the different inventory agencies, whether it's national or zooming into city level and so on. So it's finding those sweet spots where we can really help and where they can really gain, and that'll take a bit of work. I'll just throw in a bit of a comment on the, there was a question about Germany and the Autobahn. I guess whether, and changing the speed, putting a speed limit on, whether that can be detected, for example, via satellites or whatever, will depend a lot on the baseline period that you have and the background. I guess this would be more a question for some of the others, whether you can get it with other co-emitted species or something. But these sorts of things you can answer pretty well with a model of transport, a car modeling of the car. We know very well the amount of fuel used. We know how much carbon is in the fuel. So you don't need 100 million satellite and big research projects to figure out that driving, putting a speed limit on the Autobahn will reduce emissions to X%. You should be able to calculate that relatively accurately. Probably the hard part is having a good overview of the average speed of different cars, but you can get that with the transport model, I think. So not all questions need that sort of observation. You can use other methods, and sometimes other methods are better. So I tend to think we should think, what's the question we want to answer? In this case, it's, what's the effect of the limiting speed on the Autobahn? What is the best tool to answer that question? And then you approach it that way, as opposed to we have some observations, what questions can we answer? I think that's a very important thing coming from a user perspective, to find the tool that matches the question that is being asked.